Welcome back to our series on environmental consequences of engineering design. In this session, we will look specifically at the environmental issues associated with manufacturing engineered products, with a spotlight on electronics of all shapes and sizes, from the most tightly integrated circuit to conventional printed circuit board designs. In previous sessions, we looked at high-profile natural extraction issues associated with the production of electronics products, such as the choice, often placed in the engineer's hands, of whether to source gold, tantalum, tin, and tungsten from conflict-ridden or conflict-free regions of the world. In this session, we advance in the life cycle of electronics to the manufacturing of electronic devices, components, and appliances of all kinds. Although the manufacturing of electronic products can have many environmental impacts, we will look at one in particular that has hampered electronics manufacturing since the fabrication of the first transistor in the 1940s: water usage. Walking into the immense theater of electronics manufacturing around the world brings to mind the words of the ancient mariner: "Water, water everywhere, and not a drop to drink." And that is the situation in semiconductor and printed circuit board fabrication plants. In a world where over 1 billion people do not have access to safe drinking water, the electronics industry quietly soaks up millions and millions of gallons of clean drinking water every single day to satisfy the thirst for electronics for those in the world who can afford them. Almost every electronics product contains at least one printed circuit board, clothed in that familiar rigid green, and populated with a variety of electronic components, both integrated and discrete. A single square meter of printed circuit board alone can consume up to 1.5 cubic meters of water. Given that the printed circuit board industry exceeds $60 billion each year, this adds up to an incredible amount of water. Yet this is only the tip of the iceberg. Compounding the water usage of printed circuit boards is the fact that as the PCBs and the many components and chips they contain get smaller and smaller, water demand increases even further. This is because smaller devices must be extremely clean during production to yield fault-free operation, and cleaner devices require more and cleaner water. As we go from relatively large printed circuit boards to modern integrated circuits or chips, water usage goes up dramatically. A typical semiconductor or integrated circuit fabrication plant consumes over 4 million gallons of water a day. Put in the context of the quarter gallon of water minimum that an individual needs to survive every day, that's 16 million people who could go safely without thirst every day if only one semiconductor fabrication plant were to discontinue its operations. With dozens and dozens of semiconductor fabrication plants located around the world, that adds up to a very large volume of water. Compounding this problem is the fact that clean water is made from less clean water, at a price of even more water. The cleaner the water, the more water it takes to make it. In today's semiconductor electronics industry, it can take about 1,500 gallons of water to make 1,000 gallons of water that's clean enough to rinse and process the silicon wafers that eventually become tiny integrated circuits. Semiconductor fabrication plants are so big and so fueled by high demand for electronics and corporate momentum that it is hard to believe that a single engineer or team of engineers can have an impact in reducing the environmental consequences of electronics production on water supplies and water availability. Contributing to the solution depends on what type of engineer is seeking to be a part of that solution. For those that enter into process engineering and work in the actual manufacture of electronics, from the smallest to the largest, a great deal can be done to lower water usage. For example, Many processes that involve water, called wet processes, can be converted to more frugal dry processes with much reduced water usage. Cleaning, rinsing, and other steps in the complex fabrication sequences typical of electronics production also have room for optimization, much of which can conserve significant amounts of water. And of course, water can be recycled after use. In fact, ultra-pure water, even after it is used for electronics manufacture, remains more clean than city water, making it an ideal candidate for recycling at the highest rates possible. Unfortunately, most engineers in the world are involved in the consumption and use of electronics rather than the manufacturing of those electronics, putting the kinds of actions described in the previous slide to reduce water usage well out of reach. But all is not lost. The design engineer and others involved in designing electronic circuits always has the option to reduce electronic component counts by ensuring that the design meets specifications that reflect what's really needed, rather than an overreach or overspecification in functionality, which ultimately increases product cost and also the required electronics. Electronics, electrical, and other engineers involved in making circuits are in a truly unique position to understand the function of circuits and subcircuits well enough to redesign those circuits to use fewer components, and in so doing can have a meaningful impact on the water usage incurred by the products they design, manufacture, and market. While not particularly fashionable in many consumer electronics and appliance markets, modular designs are also an answer to reducing the environmental consequences of electronics manufacturing. A modular smartphone has been feasible since the first smartphones appeared on the market. Yet the willpower and momentum to make and market one has not yet reached critical mass. Considering that cell phones now contain more integrated circuits than computers around the world, moving toward modular design in these and other large electronics markets can go a long way to reducing the environmental consequences of the electronics industry as a whole. In summary, engineers can reduce the environmental consequences of electronics manufacturing, whether they are directly involved in their production and assembly, or less directly involved in sourcing and using them in other products. A wide range of opportunities lay in the engineer's hands to reduce water usage and other environmental costs associated with electronics, at all levels, from initial design to product marketing and maintenance. This concludes our snapshot of the environmental consequences of manufacturing in the world of electronics production. Thank you for joining us today. We certainly hope that this session has provided additional insight into how the engineer can reduce the environmental impacts of electronics production, and that you'll join us again as we look at other examples of environmental consequences in this series on real-world considerations in engineering design.